Hello, hello, hello. This should be now everyone should be able to hear me. Perfect. All right. Thanks everyone for the delay. Thanks everyone. Sorry everyone for the delay. There has been a few technical issues going on, but I hope everyone can hear me now. Yes, I'm very happy to see a lot of you in the streams and engaged and waiting for the presentation. Today, I'm going to talk a little bit about zero trust principles in DevSecOps. But before we jump into the topic, I would like to say, feel free to ask questions, write them in the chat, write them at Discord. I'm gonna try to engage with you guys as much as possible. Yes, to start. First of all, who am I? My name is Elias Demirtas. I am the application security team lead here in Austria, in Deloitte Vienna, and I've been working in the consulting industry for about 5 years now, since 2019. Have a lot of programming experience before that. Have a networking background, and really like the whole developing process. Trying to see and innovate new things, and also work a lot in the terms of threat modeling and just looking at how one can efficiently build and transform different setups. And for the agenda today, I would first like to introduce Deloitte a little bit, just so you guys understand where I'm from, what I do, and what the focus points are. And after that, I would jump right into zero trust in DevSecOps. So the obligatory Deloitte slide. Who is Deloitte? Deloitte is the #1 security consulting services globally. We have been for the last 12 years. We have around 21,000 professionals globally, and around 380 in the German-speaking realm. Something really interesting is the EMEA Cybersphere Center. We have a Cybersphere Center in Madrid, where we have more than 500 people in our various 24/7 topics. In there, we basically, for example, also do a lot of secure coding analysis, SAST and DAS, and try to deliver these services to the clients. As I said, Deloitte is a consultancy. We focus on advice, implement, and operations, and I'm also basically with the application security team. I'm also across all of these three borders. We try to advise the client, look at what is the current problem that they have and how they can solve it. Also going to implementations, for example, the zero trust architecture, how one could implement it, how that would work, and afterwards also looking how to maintain the working infrastructure, basically. Yes, I just wanted to give a short introduction, as we are already quite late in time. I would just jump straight into zero trust. So first, I would like to start with the development of cybersecurity itself, right? We in the 1980s, basically, this whole started as a protected protected environment. You basically had one network together, secured by literal physical security, so nobody could actually access the network if they weren't there. Everything was in a wall and was encapsulated, basically. And this quickly changed when the first internet and communication layers came into the network. Like in the 1990s, the first breakpoints for internet access were established, and you actually, as a company, and as I would say any developer, you had to think about the north-south protection, right? What comes into my network and what goes out of my network. Basically, the wall was broken. Today, it gets way more complicated. We have multiple breakpoints. It isn't just one connection into the internet. We have multiple ISP connections. We have a lot of SaaS or SaaS, software as a service. We have infrastructure as a service. We have a lot of things going on. We have a lot of hybrid environments going on, and a lot of breakpoints that we basically have to monitor. The solution for this was monitoring east-west protection, really looking at what is happening inside of my network and how can I make sure that nothing weird is happening. How can I make this secure? This is one of the main problems that a lot of companies currently are looking at. And one of the solutions that basically the future is going to is a more zero trust architecture. And for the last point, I have a detailed slide that basically explains the zero trust environment. The zero trust environment has a lot of fundamental principles. One of them is never trust, always verify. And it's basically about, in every single connection between the different devices, between users and devices, or also IoT devices, we have a different connection, right? And we always have to trust if that connection is secure. We don't rely on a border. We don't rely on just giving a user access and then going with it, but we always continuously verify if this connection between the user and between the applications is correct. This works through context and signals. I have some context or signals on this slide, basically saying the identity of the person, policies, behavior analysis, and security logs. Basically, how this works is the policy engine has a context. It has to verify. It looks at who are you, what kind of user are you, and where are you as a user. You know, are you for example, I sit in Austria. Am I in the office, or am I right now on vacation in the Caribbean islands and I'm chilling on a yacht? This is something that basically the context engine looks at. It also looks at what kind of access do you need. This also ties in together with behavioral analytics. Basically, is it unusual for you to try to get access to a certain thing? And what kind of, let's say, security level does the thing have that you are trying to access? And also what it is looking at is if you are safe. This can go through multiple levels. It can be basically, is your device safe? This can be made through different policies. It can basically look if you have all the policies that you need from your company, if you have the antivirus running, if you have the scanning running, or it can also be more complex and go over multiple devices. After we basically have the policy engine, this goes into the policy enforcement, which means it basically gives you a rating. It looks at your connection and tries to rate the connection, see if it's something we can trust or if it's something we can't trust. If we trust you, there's no security, additional security that you have to do. You just can access everything. You can work normally. You don't have to do anything. If we don't trust you, if the trust level is not acceptable, then basically the connection isn't allowed and the connection never gets built up, right? The thing is, a lot of times, just because someone is on vacation, we don't want to throw them out of the network and tell them that they're not allowed to connect at all. What we can then do is try to increase the trust level, right? One of the normal or the most developed thing that we have currently is multi-factor authentication. So basically, if you're outside of your network and you want to get into your network, you have to verify yourself. Or if you're trying to log in from a new device that you haven't used before, you have to verify that you basically are the user that you are, and you are trying to currently are trying to get into the network. This like I said, just to recap, works on every single connection in the network. It goes between user and user. It goes between user and devices. It also goes between the users and the different applications that you have, the different data you have. Depending on the data, it can always be a different trust level. But it can it also works between the different devices. That's the most important part. How is zero trust working itself, right? I always like to explain this as basically an onion. Um, it has different drivers. It has business objectives that the company has to follow. It has regularity requirements. It has a threat landscape, like depending if you're a bank, you have a different threat landscape than if you're an energy provider or are just a manufacturing company. And of course, it has basically one of the drivers is also risks. And I like to go from the outside to the inside, talking first about the governance layer. Zero trust is something that, as a principle and as a framework, goes really across the whole company. It's not just a technical thing you implement once and say, now it's working, but it's really a strategy you have to follow. You also need to build up the architecture and maintain the architecture. You need the culture and the awareness of the people. You need the support of your employees and your peers if you really want to establish a functioning system. You still have to have operations. Just because you have zero trust, it doesn't mean that you can fully throw out any other security metric. It's still about monitoring continuously. This then goes more into this enabling layer where we talk about different analytics. You have to think about what is the data that you in your company can actually gather and look at, and what is the data that you have to supplement, and think about what is the personal solution that you can have also in your basically DevSecOps environment that we come to later. And then we basically have the core domains around the zero trust. The core domains is basically the implementation parts where you really look at and have this strategy working together. In there, we have identities, we have workloads, we have data, networks, and devices. And for today, the focus is going to be on the workloads domain. The workloads domain is basically the one that from the framework side basically has the SSDLC working on. It's all about securing applications, right? And the crucial parts about a secure SSDLC is following standards and practices that are well known and well done. Using scanning applications and just shifting security as early as possible. I would like to talk about zero trust as an enabler. This is a very high level slide that for a lot of you probably isn't that relevant, but I would like to talk about 4 domains and to bring examples for these 4 domains on how basically a threat modeling in a high-level threat model in zero trust could work, and what you could think about once you're trying to establish a secure SDLC together with your zero trust architecture. So we will talk about first the developer access. This is in-house and third-party. A lot of companies have third-party developers. Not everything is in-house. A lot of companies, especially in the development scene, we see a lot of bring your own devices, which is really interesting and a really hard problem to solve for a lot of people, because once you have a bring your own device, it's basically I would say shit fest for security, because you can't manage a device. or if you can manage the device, a lot of times the people don't want you to manage the device because they don't want to give you administration rights on their device because they feel like their privacy is being intervened at. But they also don't like the flexibility that they have on the company devices. And a lot of companies can't really fully, depending on the size of the company, they can't fully rely on managed devices only. Then I would talk about the source code development. What are the entry points in the source code development and how you can basically secure that. And the same goes basically for the pipeline and for the environments. Also, if you have any questions, just feel free to ping us at Discord or just send a message on the live stream, and I will try to engage and ask or answer at any point. I'm happy to be flexible and also have a more open discussions if there's anything interesting or a specific use case that you see at your firm or in your practice. So the developer access, just for me to recap this slide, right? We have this the different devices and the different personnel, the different basically stakeholder, and basically the different profiles that a person can take on. It can be an in-house developer who basically then has different security levels or different trust levels that we can implement. There's a third-party developer that we trust less, depending on we don't give them full access to everything, or we just give them access on this specific part of the company, but we ignore the rest of the company that the in-house developer has access to. We have a cloud engineer that doesn't need the same access rights, it doesn't have the same requirements. We have operations, we have managed and bring your own devices, as I said earlier, with different levels of problems. These together goes basically into this central policy decision and enforcement center, which takes the signals in and decides if it can be trusted, if we need more trust level, or if we have to block it, right? And this then basically feeds into the secure software development lifecycle. Together with, in here we have it on pretty high level with the build artifact, with the dev environment, we have the pre-prod environment, and we have the production environment. For now, we are not going into the details back there, but we are talking about establishing the connection, right? So in a scenario, what we have here, we do not inherently trust, right? Always assume a breach, never trust inherently. We have the first scenario with developer access request to code repositories. The risk we have here, if it's not verified, is that we could have an account takeover if there is if there's an incomplete verification, basically. And here the measure we have is the implementation or the evaluation of the developer access based on the context. Just to recap again, what is the context? The context is still who are you, where are you from, what are you trying to access, right? We have continuous access levels. Just like I said, it is a continuous monitoring. Just because we trust once, it doesn't matter that we fully trust all the time. We have to look if the connection keeps or is secure. There could be basically the developer could take a break and go away for 15 minutes and forget to close his laptop, and another person could basically try to get in, go into the code and insert some malicious backdoors without the developer knowing it. This could also be done in a session hijacking while the developer doesn't even know that the session is being hijacked. For this, we basically need this continuous monitoring of the risk levels to see how it's developing and how everything is going. Another risk or another scenario that we have is that basically individual developers or teams set their own permissions and access controls. This basically means that as an organization, you have lack of control over access data, And even if you have a specific use case for that, if you say, hey, I let the team manage this part of the environment, and I as a company, I don't want to think about that, even then you basically have to have policies that secure your least privilege access, especially to each repository. And the important part is that this basically works through a centralized platform. And another interesting scenario that could be an attack vector is developers having access to both development and production environments. So this is also a little bit more into the least privilege direction, but if you have excessive permissions, there could be the problem that even, I don't say that the developer itself is malicious, but if the developer gets hacked, or if somebody gets access to the laptop of the developer, they could access environments that you don't want to access, and they could get context in terms of a data breach that you don't want to have. And for this, it's important to think about the segregation of duties inside the development lifecycle. All right. And I just saw that we have a few questions coming in. Just to finish this slide real quick, these are just some examples that for high-level examples how this could work and how different scenarios there are, or what different scenarios there are, right? What's really interesting and what's always fun to do, and I really like doing that, we also do that inside our company often, is basically threat modeling and just looking at the different attack vectors and trying to figure out these scenarios and find an answer to these scenarios. There's a lot more attack vectors inside the verification and basically the developer access, I can tell you that, but we don't have time to go over every single one, right? To go, just to answer some questions that I saw, do you use a central policy platform, or do I have an example? We as Deloitte have one. We have a zero trust platform and a zero trust environment that we have deployed for ourselves. And we also have a lot of, let's say, a lot of programs that we have developed, right? I also know of some policy engines that we partnered with, but I will have to get back on to you with that because I just forgot the names. What is the best way to instrument the continuous monitoring and be able to process that via policy engine? So what you have in here is basically you have a policy engine that has connections to your different security tools that you're using within your company. You would have your endpoint protection on the laptop itself, right? And the endpoint protection that you have, depending on what vendor you use, sends signals to your centralized security hub, basically, which is your policy engine, or which also can be connected with your policy engine. It all depends on the size of your company. You can build it in a let's say smaller environment, but especially if you are within an enterprise, it can get really complex really fast. Yes, I hope that answered the questions. If you have any follow-up questions, feel free to just write them in the chat and ask a little bit. All right. So next I would go, sorry, my laptop is not trying to work itself. Perfect. Next, I would jump into source code development. So the first step we had is we talked about the access. We talked about the access rights. And now we go into what is going on during the development. We already verified the connection, and we are in the next step where the person is really working in the code. one really important thing, just like I said in the onion before, security awareness is a key factor of security, right? The weakest link in a company is always the human factor. Humans tend to believe a lot. We have a lot of incidents, a lot of things that we talk about in security awareness. For example, is tailgating, right? Not exactly zero trust, but if you stand there and you smoke with your colleagues, and then you tell them that you forgot your key card, 90% of the time they let you into the building. That's just the human factor. If you talk to people, people like you, people let you in. People talk to you, people give you information. It's really important to build up this awareness. And the same basically goes with secure coding practices, right? If the developer doesn't know how to securely develop code, what to think about, and how to improve it, they will never be able to write, or they will be able to write secure code, but you will have a lot of overhead later on trying to fix the code. One of the measures that can be implemented here is integrating secure coding assistance into IDEs. This is something also, for example, that Sneak does. They have basically plugin for every single IDE that gives tips on how to improve the code that one is writing currently. Also important, code changes. Code changes should always be scanned because you don't want to merge unverified code. You don't want to put code into your main repository without being sure that this is secure code. Also, especially if third-party libraries are involved, a huge data and security problem are always the third-party libraries, right? I think all of us can remember Log4j and what kind of impact that had, and what kind of chaos ensured in the hours after the vulnerability was found. And one of the measures that one can implement here is to have a software bill of materials, an SBOM, and also to scan that SBOM through basically SCA scanning and see if there's any known vulnerability in the versions that one is using. I know some tools that can basically do that just with the SBOM, but you can also really go deeply into that and scan your whole code within together with basically what you used from the library. And then we basically have code repositories. Code repositories, of course, should also be secured and should have secret and credential scanning. You should always look at where you basically save those things, especially if you have database connections and stuff like that. Yes, just like I said, these are again some high-level topics, some high-level explanations of what can be problems or what can be an attack vector. And this is basically the gist of what zero trust is, right? Zero trust is this continuous security across your whole life cycle, not only in the DevOps, but also in your whole company. Now, if for example, a question could be, or a question that always arises is it enough to just secure one area of the company, for example? I mean, we have conditional security in the whole company. This is always very important. But for example, I had one use case where a customer said that they specifically want to secure their basically application environment or their developer environment, because that they have the problem that there's a lot of third-party developers coming in. They have a lot of hop on, hop off. They have a lot of freelancers that are working on the projects for a little bit of time, but not for a long time. They switch a lot of people, and they have this bring your own device policy. but they don't have that in the rest of the company. The rest of the company is basically staffed with only internal staff and have regulated working schedules and regulated security. And there, basically, the solution was just to specifically secure the development environment, to basically give the developers a secure environment to work on, a zero trust framework to basically develop and to implement. But the rest of the company just worked normally as it always did. Then, talking about pipeline security. Pipeline security, again, it's basically the same schema, so I'm not gonna go too much into detail. But a scenario that is a problem, for example, can be a problem, is integrating or the integration of custom tools into pipelines. So that means your developers had a problem, but they didn't have, let's say, a verified tool that was able to fix the problem, and they wrote a script of their own. It's very important to look at what these scripts actually do and how they work, because this is a common security problem where if they, for example, use a third-party library that shouldn't be allowed, or if they downloaded a specific version of a tool just to try to work on that, but they downloaded it from, for example, an unsecure website, this can bring a security risk into your pipeline immediately, which can then basically infect your whole environment. It is also important to use infrastructure as a code templates. It's very hard to maintain your own version of a template, and it's always nice to use a secured and a standard version of it, right? This is also something that you don't update very often. You don't continuously update your EAC templates, because if you would do that, you would have a lot of work, and you would have need to have a lot of FTE or full-time personnel just working on your templates, keeping them updated and keeping everything secure. The same goes for containers and also applications and runtimes. It's important to secure those. There could be basically the problem of different injections that you can have, and there it's important to use scanning tools. There's a lot of good scanning tools out there. There's a lot of free versions of scanning tools, which are already a start. So there is no excuse not to scan the code. Even if it's not, like, let's say, economically feasible in the moment to really buy a tool, but it's always possible to get an air-gapped on-prem environment. You put it on your laptop in an air-gapped environment, you put it in a VM, you secure it, and then you basically scan the code just locally. It's not the best that there is, but it is already a start, and it goes into the right direction. And then lastly, talking about basically the environments, securing the environments itself. A scenario could be that the application is about to be deployed into production. And the verification is needed because potential security vulnerabilities increase the attack surface you have, right? If you put up a code into, or an application, a fully built up together application into the production environment, there are still a few steps that you need to do. Even if you have, let's say, fully scanned the code, that doesn't mean that when you put the code together, there's no vulnerability at all. Something that here you can do is basically do performance testing and penetration testing on this application. This also doesn't mean you have to penetration test every single update and every single application that you're putting in. But you have to think about what are the rules. No, that's all what zero trust is. What is the risk acceptance that you're willing to take? And where are you going to say this is a major release, this is a big application, this is something a lot of people are going to access, this is important that we test and verify and see if it's really working. Yes, so this would be it about the different, let's say, versions of zero trust in this high level, let's say, checkup. I see there's a few new questions. What are your thoughts on dynamic application security testing? So from my side, dynamic security application testing is something that can be very important for your company, especially if you have a lot of code, or if you have a lot of applications that are live or only live in runtime. For example, different websites you have. It can be a very insightful tool, let's say, to get information going on. If you have, let's say, just a backend application, you wouldn't need to dynamically test that. There would be enough, it is enough if you basically do the static code analysis, you see that there is no vulnerabilities in the code execution, and you secure your backend infrastructure, basically. I hope that answers the question. How do you monitor controls in place and their effectiveness? So there is a few frameworks and policies that you can think about, right? The one very good zero trust architecture or policy framework that you can think and look at is the Microsoft one. And at the end of the day, what you look at is you try to put security as early on into your secure software development lifecycle as possible, right? The less issues you have at the end of the life cycle, the less you have to fix and go back to, the more effective the controls or the measures are that you implemented. Now, depending on the tools you use, you can also look at different reports, and you could really go into detail and try to see where do you get good results, where are your false positives low, and where do your developers put in the most time to fix or to improve the system itself. These are different, let's say, KPIs that you can look at and that you can basically use to grade the effectiveness. I hope that answered the question. If not, feel free to ask a follow-up. And then just to basically recap, this is the last slide of the presentation, just to show how this all comes together, is basically a full DevSecOps pipeline integrated with zero trust. You have your users and devices at the top that establish a connection with whatever you need, with the part of the environment you're trying to access, your dev environment, you're trying to access your repository, and the connection is being established and the trust is being verified. And through your policy engine, through your different streams that you have available in your company, it's continuously being graded and looked at if the connection is still trusted or if an intervention needs to be done. Worst case scenario, or the best thing you can do is, even if you basically cut the connection and then not allow the developer to have a connection to it, you maybe lose a bit of progress. But depending on the criticality of the software or the criticality of the task that is being done, a security attack could be way harsher than the little bit of time loss you have in reconnecting or putting in your PIN with the multi-factor authentication. Exactly. Here, basically, in the middle of the slide, we have the evaluate developer access based on context. We have the continuously monitoring. That's also what I said. The least privilege, only get access to what the developer really needs to access. The implementation of the separation of duties to make sure that not one person has access to every single part of the environment, not like, let's say, a site administrator that or a user account that isn't being used, but really one person that can just do everything they can without being checked. That's, of course, something you don't want to have. And the pipeline itself is basically, as you can see, a normal DevSecOps pipeline. It goes into a new feature. It goes through the application lifecycle management, which are basically everything. Every one of these are DevOps principles. Then we go into a security architecture and design, which is basically a security technology question. Then you can look at your threat modeling, which then again is a security policy, where you then ask yourself if you go inline into a CI/CD, or if you take it offline and go through the process that we know. And at the end of the day, you go out into continuous logging, monitoring, and behavioral analysis that you have at the end of the pipeline that goes through the whole thing. Please provide the presentation. I will talk to the DevSecCon and see how we can make that happen. Yes, so this would be the recap, or this would be the overview of how Zero Trust can be implemented into a DevSecOps pipeline, and how it can basically work, and what the high-level things are that you have to think about. At the end of the day, this is a very complex topic that we had multiple workshops on, talking with different clients, but also talking internally how we can always continuously improve the architecture that we have at Deloitte. And this is something that for me personally is very interesting and very fun to work on. If you have any questions, my contact details are on the website, and you can reach out to me. I'm happy to talk. I'm always happy to exchange information, to see how you guys see it, how it works at your companies, or how you saw it in let's say in the different environments that you were at, because security is just something that we can do together, right? It's something that everyone has to stand behind. This is not something that we try to annoy people with, but it is something that we as a movement have to do. And can you present threat modeling in the next session? Threat modeling is also something very interesting and very fun. A lot of different methods that you could use. And this is something that we will take under consideration. And great presentation. Thanks very much. I had fun presenting. Again, like I said, feel free to reach out. If there's any more questions, I'm happy to take them. I wish you guys a wonderful day.